A crucial decision you will make when designing your API-first solution is selecting the API protocol. This will be established during Step 1, designing your API contract. The protocol defines how your API connects to the internet and how it communicates information. The protocol you choose will determine how you design and build your API, as well as what's required to maintain it, so it's important to understand the advantages and drawbacks of each choice. This is the style in which users will engage with your API, so choose wisely. Let's take a look at some of the most common protocols you might consider. We recommend using a REST or Representational State Transfer API for your e-commerce solution. It is the most popular and well-known protocol because of its standardized and relatively simple structure. REST APIs retrieve data by accessing URLs. While simple, RESTful APIs follow specific design principles. Client requests must contain all the necessary information for the server to process them. RESTful APIs do not maintain any client state or previous information related to the client on the server. REST APIs expose resources, which can be any piece of information like users, products, or carts. Each resource is identified by a unique Uniform Resource Identifier, or URI. REST APIs have a consistent and standardized set of operations that can be performed on these resources. These operations are mapped to standard HTTP methods: GET, POST, PUT, and DELETE. In addition, standard HTTP status codes are used to determine the success or failure of an API call. For example, 404 not found means a resource does not exist. Resources in a REST API can be represented in a variety of data formats, with JSON, or JavaScript Object Notation, being the most popular. XML, or Extensible Markup Language, is also a common data format. A drawback of the RESTful API protocol is that it will only transmit information via HTTP protocol, so it is limited to sending text only. It is important to note that this API protocol will not flag errors in how API calls are formatted. It is incumbent upon the API designer and consumer to ensure requests are correct. GraphQL isn't a separate protocol, but rather a distinct query language for APIs, originally developed by Facebook. GraphQL allows you to request specific data from the server. In simple terms, GraphQL tells the API what data it wants and in what order. REST, in comparison, will only retrieve set data structures, meaning you will only be able to pull data that was defined by the server, not what you specifically need. When GraphQL was created in 2012, it was effective at improving mobile app performance used on slow wireless connections. Now, wireless connections are faster than wired broadband of the time, so the speed of GraphQL is no longer a leading benefit. GraphQL queries allow developers to retrieve only the data they require. REST APIs have multiple endpoints associated with resources like products. So to retrieve all the data you need, you will need to make multiple API calls. GraphQL centers on the task, so you are able to get the information you need with a single API call. When there is an error during a GraphQL query, you will receive a detailed error message listing the specific part of the query that is throwing an error and how to resolve the error. With REST, HTTP headers indicate the success or failure of a request with no further information. GraphQL sounds pretty nifty, right? It seems to save you time and energy when compared to REST, but GraphQL has its issues. Let's take a closer look at some of the downsides of GraphQL. The learning curve for GraphQL is much higher than REST, as it doesn't leverage standard data formats or HTTP methods. A GraphQL query looks similar to JSON, but has enough differences to trip up new developers when leveraging GraphQL for the first time. Users must follow consistent query syntax, which can be complex, to pull required data. GraphQL learners will need to know what fields exist in order to query correctly, which means relying on thorough and detailed documentation. This can take time to put together, slowing down your implementation process. While enabling clients to request exactly what they need, GraphQL queries can encounter performance issues if a client request includes too many nested fields at once. To prevent issues, GraphQL queries need to be formatted in a specific way. So to be on the safe side, it might be worth using a REST API for complex queries. While many people compare GraphQL to REST, it has trouble competing in high throughput or enterprise-level applications. Take a look at the chart listing some of the reasons different organizations struggle with GraphQL. Interestingly, the pain points of GraphQL seem to be strengths for REST and key requirements for high-volume enterprise systems, such as caching, security, and performance or scalability. RPC, or Remote Procedure Call Protocol, allows developers to make calls on external servers as if they were local. While REST, GraphQL, and SOAP APIs work directly with data resources, RPC APIs work with processes or actions. For example, a business can retrieve a customer address by remotely calling customer information from a database. There are many varieties of RPCs, with the most well-known being gRPC, or Google Remote Procedure Call. gRPCs, like most RPCs, define services, detail methods that can be called remotely, and their parameter values and return types. gRPC is best suited for building microservices architectures and real-time applications. While it can be leveraged for composable architecture, it is often beneficial to have all APIs follow the same type, and gRPC is not widely adopted. This leads to most composable designs opting for RESTful APIs as the clear winner in both performance and ease of use.